We're now going to have a look at the reactions that alkanes undergo. Now, alkanes aren't classed as very reactive molecules or very reactive compounds. And the reason for that is that the sigma bonds within them, so the sigma bonds between the carbons, between the carbon atoms, they're very strong. So they require a lot of energy to break, and therefore the reactivity of the alkanes is not very high. Also, the bonds between the carbons, so the carbon-carbon bonds, are non-polar, which means that the electrons lie in the middle. The electronegativity of the carbons and the hydrogens are very similar, and therefore we class the carbon-hydrogen bond to be non-polar. What that does is it makes the whole molecule non-polar. So alkanes are classed as non-polar molecules, so that's another reason why they're not very reactive, combined with the fact that the sigma bonds are very strong. So there's two types of reactions that alkanes can undergo. One is a combustion reaction and the other one is halogenation. In this video, I'm just going to focus on combustion, and the next one will be on the halogenation. The combustion of alkanes is quite useful. They do burn very well. So combustion is just burning something, and because they burn very well, we can use them as fuels. We can use it to generate energy, and that's why we use it on a large scale. When it comes to combustion of alkanes, there are two types of combustion. One combustion is complete combustion and the other one is incomplete. So we're going to look at complete combustion first. So complete combustion means you are burning your fuel or you're burning your hydrocarbon in excess oxygen. So there you are doing it in a well ventilated area. So it's done in excess oxygen. And whenever we do complete combustion of a hydrocarbon, we must always form carbon dioxide and water. So complete combustion, the products must always be carbon dioxide and water. So the example, I'm just going to start with a simple one. I'm just going to do methane. So I'm going to do the combustion of methane, putting in state symbols. So it's a gas. Whenever we burn something, we're reacting with oxygen, so oxygen gas. So we're always going to form carbon dioxide gas and water liquid. Okay, and then all we've got to do is balance this equation. So in order to balance it, I need a 2 here and a 2 here as well. Okay, so that is the complete combustion reaction of methane. You can do the complete combustion reaction for any of the alkanes, as long as you are remembering to always form carbon dioxide and water. You then just need to balance the equation. The other type of combustion is incomplete combustion. And incomplete combustion is not favourable because it doesn't release as much energy as complete combustion does. So incomplete combustion is done when we have limited oxygen. So there's not a good supply of oxygen around. And there are essentially two reactions, or two types of reactions that we can write here. One that you can write is when you burn that compound, you are forming something called carbon monoxide and water. Or you can do a reaction equation where you are forming pure carbon and water. Okay, so there are two possible incomplete combustion equations we can write. So I'll do both of them for methane. So for methane, the one where we are forming carbon monoxide gas, so carbon monoxide is a gas, and water, so that's the equation for that. If I want to balance that, that is 2 here and 3 over 2 here. Okay, so this is one equation we can write for the incomplete combustion. Bearing in mind, so carbon monoxide, so what the reasons that these are unfavourable is because carbon monoxide gas here is a toxic gas. It's a toxic odorless gas, so if it is around us we won't know, and it can be fatal if we breathe it in for too long. So that's another reason why it's unfavourable, as well as the fact that it doesn't release as much energy as complete combustion would. The other equation that can occur, so again in limited oxygen, we can actually form pure carbon. So pure carbon in this form is like soot. It's like a black powder that forms, and we also form our water as usual. And then to balance it, that is now balanced. Okay, so these are the two possible reactions that can happen when we do incomplete combustion of a hydrocarbon. So one is where you form carbon monoxide and water. The other one is where you form carbon and water. Carbon is unfavourable because it's, as I said, it's soot. It blackens buildings. It doesn't make it look very nice, and also the little soot particles aren't good for people with respiratory issues.